In this video tutorial, I'll be looking at 6.4 trigonometric identities. 6.4 represents Chapter 6, Section 4 of the Pearson A Level Maths Pure Maths Year 2 textbook. So let's have a look at some juicy identities. The very first identity that I'm going to look at is this one over here. Sine squared theta plus cos squared theta is equal to 1. This identity is true for any theta. Very important, it's only true for power 2. Okay? So, we can't have that sine cubed theta plus cos cubed theta is equal to 1 because this identity is only true for power 2. It's true for any theta. So, for example, I could have sine squared theta plus cos squared theta equal to 1. Right, let's have a look at another identity. The second identity that I'm going to look at is this one over here. Tan theta is equal to sine theta over cos theta. This identity is true for any theta and for any power. For example, if I square both sides, I get tan squared theta equal sine squared theta over cos squared theta. Okay, if I cube both sides, I get tan cubed theta equals sine cubed theta over cos cubed theta, etc. And it's true for any theta, so I can have tan theta is equal sine theta over cos theta. Let's have a look at the third identity. The third identity is this one over here. 1 plus tan squared theta is equal sec squared theta. This identity is true for any theta. Okay, and it is only true for power 2. So I can't have 1 plus tan cubed theta equal sec cubed theta. It's not true because I said this identity is only true for power 2. In the same way, I can't have 1 plus tan to the power 6 theta equal sec to the power 6 theta because this identity is only true for power 2. Right, it's true for any theta, so I could have, again, 1 plus tan squared theta is equal sec squared theta. Let's look at the fourth crispy identity, and the fourth one is this one over here. Okay, 1 plus cot squared theta equal cosec squared theta. This identity is true for any theta, and it is only true for power 2. Okay, so you can't have, for example, 1 plus cot to the power 10 theta equal cosec to the power 10 theta because this identity is only true for power 2. Now I said to you guys that this identity is true for any theta, so like we did over here, here and here, I could write down 1 plus cot squared theta is equal cosec squared theta. Okay, so these are our identities 1, 2, 3, and 4. Okay, right. What I'm going to add over here is sec theta, cosec theta, and cot theta. So sec theta, we've covered this before, is equal to 1 over cos theta. Okay, you look at the third letter over here, it is C, so 1 over cos. In the same way, cosec theta is equal to 1 over sine theta. The third letter is S. Okay? We also had that cot theta is equal 1 over tan theta. The third letter is T. Now 1 over tan theta is equivalent to cos theta over sine theta. Okay, over here cos theta not equal to 0. Here, sine theta not equal to 0. Over here, tan theta not equal to 0. And sine theta not equal to 0. So we've got our four identities here. We've got sec theta, cosec theta, cot theta. We are now going to apply these to questions. Right, so now we have question 1 and question 2 to tackle some juicy questions. The first one, it says simplify this trigonometric expression. What I can see first of all is that there is a common factor of 4 cosec squared 2 theta between the two terms. So I can take out 4 cosec squared 2 theta. That would be my first natural step. Okay, 4 cosec squared 2 theta. You take that out, in bracket, we get 1 plus cot squared 2 theta. But 1 plus cot squared 2 theta is just cosec squared 2 theta. So I get 4 cosec squared 2 theta multiplied by cosec squared 2 theta. And this simplifies to 4 cosec to the power 4 2 theta, and that there completes the question. Question number 2, given that cosec x is equal to k over cosec x, where k is greater than 1, find in terms of k possible values of cot x. Okay, right. Now, cot x, cosec x. I know a very juicy identity that connects both cot x and cosec x, and that identity is this one over here. 1 plus cot squared theta equal cosec squared theta for any theta, and it's only true for power 2. So what I can do is first of all try and obtain cosec squared x. The way I can do that is by multiplying both sides by cosec x in this particular equation. So if I do that, I get cosec squared x equal k. Now, I need the values of cot x. So, to obtain the possible values of cot x, I need to eliminate cosec squared x. I know that cosec squared x will just be 1 plus cot squared x. Okay, so 1 plus cot squared x is equal to k. Now, all I need to do is make cot x the subject. So, I get cot squared x equal k minus 1. Now I need to take the square root, and when I take the square root, I need to ensure that I include a plus or minus. And there you have it. The possible values of cot x is the positive square root of k minus 1 and the negative square root of k minus 1. And that completes both question 1 and question 2. Let's have a look at question 3 now. Question 3 says, given that sec theta is equal minus 3, where theta is more than pi over 2 but less than pi, part A, calculate the exact value of tan theta. Part B, show that cosec theta is equal to 3 square root 2 all over 4. Now, before we look at this question, in the exam, if they say theta is acute, then theta is more than 0 but less than 90. So the range for theta is as follows. Is more than 0 but less than 90 degrees. Or 90 degrees in radians is pi over 2. Okay, if theta is obtuse, theta is more than 90 but less than 180 degrees. So more than 90 degrees but less than 180 degrees. Now 180 degrees in radians is pi, and 90 degrees, like I said before, is pi over 2. If theta is reflex, then that means theta is more than 180 but less than 360. Hence, I can write the following range. Theta is more than 180 degrees but less than 360 degrees. 360 degrees in radians is 2 pi. And 180 degrees in radians, like I said before, is pi. Okay, right, so that was very important. Let's go back to the question. For part A, there's 2 methods. Method number 1 is to use the identity, well, one of the identities over here, to actually work out the value of tan theta. Method 2 is to use the triangle method. So let's have a look at method 1. So method 1 is the identity method. I want to work out the value of tan theta. First of all, I'm going to start off with sec theta equal to minus 3. I know a very important identity that connects sec and tan, and that identity is this one over here. 1 plus tan squared theta equals sec squared theta. The very first step is to square both sides in order to apply this particular identity. So if I square both sides, I get sec squared theta equal to 9. Now sec squared theta is just 1 plus tan squared theta. So I can replace sec squared theta with 1 plus tan squared theta equal to 9. Now my target is to make tan theta the subject. So I'm going to do that now. Tan squared theta equal to 9 minus 1, which is 8. Take the square root. So plus or minus square root of 8. Simplify that. Okay, I get plus or minus 2 root 2. Now, what I need to do is to determine whether we'll take the positive or negative value. The way to do that is to go back to my range for theta. Okay, theta is more than pi over 2 and less than pi. So if I draw a cast diagram, I have something like this. That's pi over 2, that's pi. So the angle will fall in this quadrant over here. C, A, S, T. In this quadrant, only sine is positive, the rest is negative. Hence, I take the negative value for tan. So tan theta is equal to minus 2 root 2. And there you have it. That's the end of method 1. Let's look at method 2. For method 2, I am going to be drawing a triangle using the fact that sec theta is equal minus 3. First of all, sec theta is 1 over cos theta. So we have that 1 over cos theta is equal to minus 3. Okay, if I take the reciprocal of both sides, I get cos theta is equal minus 1 over 3. Now, I know that cos theta is adjacent over hypotenuse. So I can form a right angle triangle. Okay, so here's my right angle triangle. The adjacent is 1 and the hypotenuse is 3. The reason why I take the positive value and not the negative value is that the lengths of a shape is always positive. Hence you take the positive value. So in this case I take positive 1 and over here positive 3. Now what I can do is apply Pythagoras theorem to work out the opposite. So the opposite will be square root of 3 squared minus 1 squared. And 3 squared is just 9. Minus 1 squared is 1. 9 minus 1 is 8. Square root of 8. If you simplify and write it in third form, it is 2 square root 2. So 2 square root 2. Right. I've got cos theta. It's minus 1 over 3. From that triangle, I can read off what sine theta will be. Well, sine theta, we know from GCSE, is just opposite of a hypotenuse. So, the opposite is 2 root 2. Okay, and the hypotenuse is 3. I put down plus or minus. I need to work out whether it's the positive number or the negative number. Go back to your range for theta. It's more than pi over 2, less than pi. The angle will be in the S quadrant. Now in the S quadrant, sine is positive, the rest is negative. Hence, I will take the positive value for sine over here. So sine theta is equal to the positive value. So you take the positive, so you just write 2 root 2 all over 3. Now I've got cos theta, I've got sine theta. All I need to do is apply the identity tan theta equals sine theta over cos theta. And if I put cos theta and sine theta into the identity, I obtain precisely minus 2 root 2. And that's the end of method 2. So in general, you can use identities to solve these problems, or you can form a triangle. Let's look at part B of the question. It says, show that cosec theta is equal to 3 square root 2 all over 4. Now, cosec theta, we know that it's just 1 over sine theta. But we've calculated the value of sine theta. Sine theta was just 2 square root 2 all over 3. So I substitute that in, so I get 1 over 2 square root 2 over 3. Okay, and if I actually simplify this, I obtain the value 3 square root 2 all over 4 as required. And that there completes question 3, ladies and gents. Let's move on to question number 4. I would like to solve this trigonometric equation for this interval for theta. At the moment, I've got a tan and a sec in this equation. What I can do is notice that this tan squared 2 theta can be eliminated from the equation. Okay, what we can do is use this particular identity, 1 plus tan squared theta equals sec squared theta. So using that identity, I can replace this with sec squared 2 theta minus 1 equal sec 2 theta minus 1. Okay, now the minus 1 on both sides will cancel out, and we have sec squared 2 theta equals sec 2 theta. What I can do is take the sec 2 theta to the other side to obtain the following equation. I have a common factor between these two terms, and the common factor, ladies and gents, is sec 2 theta. I can take out sec 2 theta. In bracket, sec 2 theta minus 1 equal to 0. So, I obtain the following. Either sec 2 theta is equal to 0, or sec 2 theta minus 1 is equal to 0. Now, sec 2 theta minus 1 equal to 0 gives us the equation sec 2 theta equal 1. So, I need to solve this equation and this equation. The problem is there is no sec button in the calculator, hence I need to actually replace the sec 2 theta with 1 over cos 2 theta. So 1 over cos 2 theta is equal to 0. Okay, what I see is if I take the reciprocal of both sides, I get cos 2 theta equal 1 over 0, but you can't do 1 divided by 0. Hence, this particular equation has no solutions. Let's move on to this equation over here. Sec 2 theta is 1 over cos 2 theta. Okay, that's equal to 1. If I take the reciprocal of both sides, I get cos 2 theta equal to 1. Now, I've got the angle 2 theta, so what I need to do is double the range. So if I double the range, I get 0 is less than or equal to 2 theta, which is less than or equal to 360 degrees. So 0 times 2 is 0, 180 degrees times 2 is 360 degrees. Now I'm going to let x equal 2 theta. Okay, so I can rewrite this particular equation as cos x equal 1. And this particular interval, I can rewrite it in terms of x. So 0 is less than or equal to x, which is less than or equal to 360 degrees. Okay, so I can solve cos x equal 1 either using a class diagram or drawing the graph for cos x. It is easier to solve cos x equal 1 by drawing the graph of cos x. So I'm going to draw the graph of cos x in this particular interval 0 to 360 degrees. Now looking at the graph, cos x is equal to 1 for x is equal to 0, and cos x is equal to 1 for x is equal to 360 degrees. Okay, so x is equal to 0, x is equal to 360 degrees. Now I'm not solving for x, I'm solving for theta. So I need to replace the x with my substitution over here, which was x equal 2 theta, so I'll replace the x with 2 theta. So 2 theta is equal to 0 or 360 degrees. Hence, if I want to work out theta, I divide each of these angles by 2 to give me theta equal to 0, theta equal to 180 degrees. So this particular equation, tan squared 2 theta equals sec 2 theta minus 1, has two solutions, and those solutions are 0 and 180 degrees. And that there completes question number 4. If you found this video tutorial useful, please don't forget to subscribe.